Hi, and welcome to my talk today. My name is Anders Wallgren, and I work at CloudBees, where I'm the VP of Technology Strategy. And today my topic is how to SRE your way to pipeline improvement. I've had the great fortune of working with our customers and our engineering teams for many, many years, working on how to improve, optimize CICD pipelines anywhere from basically commit to customer. So not necessarily focusing today on just end-to-end pipelines. A lot of this will apply to whether you're doing a continuous integration pipeline, continuous testing pipelines, continuous delivery pipelines, really, kind of across the board. This will hopefully be useful to you. So I've broken this down into a few sections. The first one, I'm just going to do a few slides talking about metrics and how to use them, how not to use them, how to drive outcomes, that sort of thing. Talk a little bit about the very small subset of SRE that I'm going to apply to improving pipeline outcomes, and then also a little bit on really what we're looking to get out of our CI/CD pipelines. Kind of the most important fundamental aspects of those, and then the bulk of the talk will be on how we're going to choose some service level indicators, so the service level objectives, and service level agreements, or as I like to call them in this context, actions that are relevant to driving those pipeline outcomes. So let's dive right in and talk a little bit about metrics first. Metrics really are the art and science of continuous improvement, really at the heart of that, right? And why metrics? Well, science, because science. Observation is really fundamental to the scientific method. What we all want to engage in here is, we have an observation, we kind of have a question about that, we form a hypothesis about why that might be. We make a prediction based on that hypothesis. We might derive an experiment, run the experiment, look at the results, and then of course we repeat. Lather, rinse, and repeat. And this is continuous improvement. And we want to use metrics as part of that. And what does that have to do with DevOps? You might say. Well, I would argue, and lots of people would argue, that DevOps really uses the scientific method as part of enabling software innovation, and that's kind of core, right? We're always running experiments, and I think you can argue that something like CI is an experiment. Will my code changes work? CD is an experiment. CT, continuous testing, is an experiment, right? And what we're looking for is feedback on how successfully we're doing those activities. And when it comes to metrics, what's really important is that you choose metrics that drive your desired outcomes, right? Where there's lots of reasons to use metrics, right? We might want to try to make ourselves look good. We might want to make ourselves look bad. We might just want pretty graphs, understand where we are, kind of where we want to be. But really the key thing is choose metrics based on outcomes that you want to drive. That's very important, and especially I think in this context. And then focus on as few metrics as possible to maintain a high signal to noise ratio. I think we've all sat in those meetings or walked into those kinds of boardrooms and conference rooms where there's tons of monitors or tons of displays showing lots of metrics, and it looks like NORAD or NASA mission control, right? That's not really what we're after here. What we're after here is we really just want to focus in on small is better. Small is better here. Just a few metrics that are going to drive outcomes that we want to achieve in our pipelines. Switching gears a little bit, and I'm going to just quickly talk about a very tiny subset of Google's SRE topic, if you will, site reliability engineering. The Google SRE book it's a great read. It's free. It's available online. Covers a broad range of topics having to do with this, and I'm really just going to focus in on a very small part of this as it relates to my thinking around how to improve pipeline outcomes, and that's really the service level aspects of SRE. And really what we're talking about there are three things: service level indicators, service level objectives, and service level agreements, or I sometimes will call them, especially in this context, service level actions. And really what we're talking about here, as the slide says, is a service level indicator it's a metric, right? It's something that you measure. And in our example here, the example kind of builds out a complete sentence, if you will. And so the first part of the sentence here is that the indicator that we're interested in is customers can log in and view their data. right? Now, around that indicator, we want to derive an objective, and really that's a target value for this indicator, right? It represents an ongoing commitment that we want to keep this indicator in a particular range or above or below a certain number. So in this case, kind of continuing to build our sentence here, 99% of the time. So customers can log in and view their data 99% of the time. And then the last part of it are service level agreements or actions, if you will. And that really is a definition of what happens when we don't meet the objective for a particular indicator, right? So customers can log in and view their data 99.9% of the time, or they can request a refund for losses incurred due to unavailability of the service. So that really, in a nutshell, is kind of, an indicator is a metric, an objective is a target for where we want that metric or that indicator to be, and the agreement or the action is what we do when we don't meet that objective. It's really that simple. And one of the reasons I just like it is it does boil it down very nicely, right? And it really gets us talking about what it is we're measuring, what it is we're looking for out of that measurement, what the action is that we're going to take if that measurement is out of whack. And with respect to metrics, as I said previously, driving outcomes using metrics is very important. And so what we want to do is we want to choose metrics, indicators that are actionable, that we can do things about when the metrics are not, when the indicators are not in the range that we want. So now just a little bit of a chat here about what we're looking for out of our CI/CD pipelines, and shout out here to Gary Groover, who's a very clear thinker on this topic, and in several of his books and presentations, and in some of my interactions with Gary, he really crystallized for me what the point of the whole entire CI/CD pipeline process is, and the fundamental, most important aspect of a CI/CD pipeline is that it represents for us a stable quality signal, right? It's something against which we can test changes to our code, changes to our environment, changes to our tests, and expect to get back a reliable indicator of whether we broke something, whether something is working or not working, how well it's working or not working. And the stability of that signal is really, really fundamentally important. In fact, when we come to talk about the outcomes that we're trying to achieve here with our little experiment here, our thought experiment, I would argue, and I think I can argue very strenuously and strongly, that the stability of this quality signal is in fact more important than the speed and performance of that. And just to be more concrete about it, the stability and reliability of our pipelines is more important than the speed of our pipelines. Now, absolutely, we want fast pipelines, right? We want the feedback fast, and especially in case of failures, but slow and steady will beat fast and flaky any day and twice on Sunday. And that's very important, because I will, you sort of stack rank your outcomes a little bit, and I will stack rank reliability of our pipeline, stability of that quality signal over how fast that pipeline runs or how quickly we get results from it. Not saying fast isn't important. Fast is very important, but stability is in my mind even important. And so that's, if you take anything away from this, one of the things I'd like you to take away is that the stability of our pipelines is of paramount importance. So given that, I've just picked here, just to keep it simple, two outcomes that we want to derive out of our kind of thought experiment here. The first one is that our CI/CD pipeline should provide a stable quality signal, right? If we, as I talk about a little bit later, if we run our pipeline 10 times in a row with no changes, no code change, no environment change, nothing, if we just run it 10 times in a row, we should get 10 identical outcomes. They should run roughly in the same amount of time, and we should have the identical result, right? If we have a test that fails once or twice or three times, or if we have an environment that fails to perform or fails to come up or times out or something like that in 3 or 5 out of those 10 runs, then we don't have a stable quality signal. We don't have a stable environment to operate in against which to test our changes. And it's key to have that stability, right? Because otherwise, we don't know whether the problem is in the change that we introduced or inherent or already present in our environment or in our tests or in our pipeline and our processes. So that's very important, and I'll drive on that point quite a few more times. But our number one outcome is we want to provide a stable quality signal here. We also then, of course, want it to run quickly, and we want it to fail fast. And I'll talk a little bit about why I add fail fast there as an additional measurement onto or outcome onto run quickly. So what we're going to do here is we're going to choose some service level indicators, some objectives around those indicators. And just fair warning, I'm not going to be very specific about the objectives as they apply to these indicators, because they're going to be all over the map. They're very contextual. If today you're doing your CI pipeline in 15 minutes, or you're doing it in 15 hours, because it's a long, continuous delivery pipeline with continuous testing and those sorts of things, then your objectives are going to be different. If you're operating in what is for you today a flaky environment where things are not very stable, then the kinds of objectives you're going to drive for are going to be a little bit different than if today you have a very stable environment and you want to keep that way. So I'm sort of going to be purposefully ambiguous about those, though I will talk to them, of course. But our goal here is kind of in a jokey way here, we want 0 days without a CI/CD failure, right? We want a job site that's humming along very, very well. So SLIs, service level indicators that we can use to drive CI outcomes. So under the outcome of stable quality signal, I've chosen 3 here. So we're gonna want to keep track of the success and failure ratio of our pipelines. We're going to keep track of the mean time to fix a pipeline when it's broken. And then we're also going to keep track of the root cause of these pipeline failures. And that's really important, because what we do, the actions that we take, are going to be somewhat dependent on why something failed, right? So we do want to keep track of that. On the fast feedback and fail fast kind of outcome, what we're going to look for is a couple of things. We're going to look at our mean elapsed time for a successful CI/CD pipeline run. And I very specifically here say a successful CI/CD pipeline. I'm not interested, I don't want to pollute the data here with how long a failed pipeline takes to run, because a failed pipeline can take a lot longer or a lot shorter to run than a successful one, right? If you've got tests timing out and those sorts of things, then your pipeline may take 2 or 3 or 5 or 20 times as long to run as when it's successful. Or if it fails fast, it's going to be very short. But what we're concerned about here is, what is the elapsed time for a successful CI/CD pipeline? And then secondly, the second indicator on the fast feedback, fail fast outcome that we're looking for is, what is the mean time to failure from the start of our CI/CD pipeline? And I'll get into a little bit why I think that's a useful indicator to use. And it really has to do with why something failed, which ties a little bit to the root cause, and then what we can do to improve upon that. And that gets into, was it a system test, an integration test, a unit test, an environment, a deployment, those sorts of things. So then I've broken the service level objectives into one slide, one for each of the outcomes that we want to drive. And under the outcome of stable quality signal, under the success failure ratio indicator, really here what we want to do ideally, of course, is drive to 0. But be realistic about your current state, right? I mean, if today, 1 out of 5 or 1 out of 10 or 1 out of 2 of your pipelines fail, then you use that as a baseline and just set a goal to improve that, and really drive towards that. Drive it to 0. That's where we want to get to. But it doesn't necessarily do any good to just say drive to 0 immediately. You may want to stage your way in there. And of course, keep in mind that the longer your cycle times are, the more painful these failures are. So we really do want to keep it as a ratio, right? The absolute numbers are not that interesting. 10 failures of a pipeline that runs for 15 minutes is very different than 10 failures of a pipeline that runs for 15 hours. Service level objectives around mean time to fix. Obviously, ideally here, we want everything to be fixed immediately, right? But think in terms of minutes and not hours. And really that goes a little bit to actions, because, so I'll preview that a little bit. But what we really want to talk about here is, look, if you can't fix something quickly, revert that commit, pull it out, right? That's oftentimes the best way to get the pipeline back to green, and then you proceed in parallel to figure out why that commit caused a problem, right? Again, here your cycle time is going to impact this, positively and negatively, in the sense that if you've got a long cycle time and that pipeline that failed is still running, you may have subsequent failures to discover, so you may want to keep it running. That does give you a little bit of air cover, a little bit of time to figure out why something failed. On the other hand, if it's a persistent failure in a rapidly running pipeline, you're pretty quickly going to have a set of people lined up outside your door, either physically or virtually, wanting you to fix this. And mean time to discovery is very related, obviously, here to mean time to fail. So that's related to this. But what I'm concerned about here is mean time to fix from the time that we discover that we have a problem. And other things that you want to think about in terms of what kind of objectives you want to throw around this is, do we have all committers involved? Are they all in the same time zone? Are we all in the same office? Are we spread across the globe? Right? That can impact your objectives. Your objectives might be a little bit different if you're the last person in the office working on trying to fix this. You might not have as much time pressure to fix this, but if you know that the sun is about to rise on one of your other teams and they're going to be impacted by this failure, the pipeline failure, whether it's a CI failure or a CD failure or something like that, then there's going to be a little bit more pressure there. So you might want to tighten up your objectives. And then the main reason why I pulled the root cause indicator in here is really for the first two, right? Because they are so important to the outcome of having a stable quality signal here. And that's flaky tests and flaky infrastructure, right? These you really want to drive to zero. And if you suffer from flaky tests or flaky infrastructure, you really probably ought to go down the road that I described before around run 10 or 50 or 100, however many it takes, of your pipelines with no changes, just over and over and over, and fix only the things that address the problems that you see under these no change conditions. Of course, a fix is a change, so that's, there's a little bit of ambiguity there. But start by running 10 of them. Just run 10 of them and see what happens, right? Collect the root causes, then go track down the flaky tests, track down the environment problems or what have you. And then the other kinds of failures are going to be more sort of the, kind of human mistakes, right? I have a bad commit, I caused a compiler failure, I forgot to add one of the files or stage one of my files into the commit, so Git didn't pick it up. We're human, we make mistakes. The whole point of CI is to catch these mistakes. The whole point of continuous delivery pipelines is to catch these mistakes before the customer benefits from them. So, if we had 100% success, maybe we're not trying hard enough to find failure, quite frankly. But, it could be a bad merge. It could be a conflicting commit, right? If we're not able to run our CI pipelines fast enough so that it's one commit per pipeline, which frankly, I don't see a lot of teams with significant amounts of code and significant amounts of tests that are able to, especially as you get kind of towards the end of a sprint, let's say, in your agile process where you might have a little bit of a storm of commits. You can very easily have one commit where my code change breaks your test, and your test is new, my code is new, and there's no way that we're going to discover that until we put the two together and see what happens. That's easier to avoid if we have faster cycles, and so we have less commits per cycle. So we might want to think about improving our cycle time, or maybe staging the way that we do the pipeline so that we run tests earlier rather than later. Those sorts of things. Moving on to service level objectives around fast feedback, fast failure outcome. Mean elapsed time for a successful CI/CD pipeline is kind of the obvious one there, right? And obviously we want all of our pipelines to be instantaneous, and all code should have zero bugs, as Bugzilla famously referred to. So the objectives that you want here they're going to be very, very contextual, right? They're going to be based on the size of the application or system, the amount of code we're looking at, the amount of tests that you run. Is this continuous integration, continuous testing? Is it continuous delivery? So it's very contextual, right? You know what you're looking for here. Be aggressive in your objectives here. Drive for zero, drive for very fast, drive for instantaneous. For some teams, anything greater than 15 minutes is going to be obvious, is going to be awful, right? And for others, if you get below 15 hours, they're going to be jumping for joy. It's very contextual. Generally our CI pipelines are going to be shorter than our continuous delivery pipelines. That's kind of the nature of the beast a little bit. And then, mean time to failure. Again, there's no hard and fast rule here, or no hard and fast objective to drive for. So maybe start with, let's make sure that most of our failures are happening in the first half of the pipeline. And the reason for this is really around, it's really around testing, right? So, if you think to that sort of the image of the test pyramid, in terms of you want to have most of your tests be unit tests because they run fast. They don't need a lot of infrastructure to run. In fact, they really, really need no infrastructure other than sort of the CPU and the code to run. And then you have some integration tests and fewer system tests. The point of tracking this metric is, and I've observed this with some of our own teams, with customer teams, oftentimes what an engineer will do is they'll only write a system test for a new piece of code. And they won't necessarily write unit tests. Well, that can be bad because that means if there's a failure, if there's a problem, you may not find that out till you're 90% of the way through the pipeline. Now, if that's a 15-minute CI pipeline, that's not so bad, but it's a 15-hour long continuous testing with lots of, security scans, performance testing, scalability, regression testing, acceptance testing, staging environments involved, deployments involved, building installers, building Docker images, doing deployments, Helm charts, all of that sort of business. Having that failure happen late is going to be painful. So, and one of the things I always encourage our engineering teams to do is when you have a failure in a pipeline and it happens late in the pipeline, ask yourself, could I have written a unit test to catch this problem earlier? What was there a way, how can I shift left that failure? Because the sooner it fails, the sooner we can fix it, right? So really think there in terms of, kind of shifting, the objective of the mean time to failure is to have it fail as far left in the pipeline as possible. So what are the kinds of agreements or actions that we put in place here around our stable quality signal objective? So on the success to failure ratio, right, here really what you're looking at is the trend, right? At the extreme, if the trend is up and to the right and it's not looking good in terms of the failure ratio, the percentage of your pipelines that are failing, I mean, you may need to stand down, right? You may need to go to that part, that painful part where you kind of pull the fire alarm and say, okay, no commits that aren't related to fixing the current set of problems that we're experiencing are going to be allowed. It's draconian. Sometimes it's necessary. When you have a failure, it's important to do the root cause analysis on that. The root cause analysis here is not about pointing fingers. It's very important to do that. What we're trying to do here is we're just looking for trends, right? We're looking for things like flaky tests, flaky environments, merge problems. Maybe we have lots of commits piling up, and so we have commit conflicts, and maybe that's driving the trend here. If you're seeing lots of flaky tests, there's a few things you can do here, right? Most of the test tools that are out there now will allow you to rerun a test if it fails and rerun it several times if you want. That can be helpful to root out and ferret out flaky tests, because if you run a test and if it fails, you repeat it up to 5 times, let's say, then if it takes 4 attempts before it passes, or 2 or 3 attempts before it passes, by definition, you're looking at a flaky test. You need to jump on that. You need to treat that as a serious problem and root it out. And if you just have general flakiness in the infrastructure or in tests, then you might need to go to that sort of approach where run 10 pipelines in a row with no changes, collect the results from that, make a series of improvements, run the 10 pipelines again in a row. These are painful things to do, but sometimes we're in that sort of scenario, that sort of situation where we need to do that. Then in terms of what to do when the mean time to fix goes up, right? So committers should be watching these results and jumping on problems. So if I've committed something into a pipeline, I need to be watching that. I need to be paying attention to that. And again, the size of the team, the geographic distribution of the team, whether we're following the sun with our development practices, those sorts of things are all play into this, right? The committers here should root cause the failures. Now, when I speak of committers, obviously here I'm thinking, generally of kind of that probably skews a little bit more towards continuous integration pipelines, but I think it applies even to continuous testing or continuous delivery pipelines. If you're dealing with a longer pipeline, are you able to restart your pipelines at the point of failure? If you don't have to do a code change to fix a pipeline failure, if you're able to, if the tooling that you're using allows you to restart a pipeline at an earlier stage and not go all the way back to, say, CI, God forbid, in order to run your pipeline, consider that. And if you can't do that, maybe what you want to do is the action you want to take is to invest in that. Also, can you run multiple pipelines in parallel? So while one pipeline is running, can I start another one that has the fix? And can I use elastic infrastructure in order to take advantage of that? And then again, on the root cause of pipeline failures, I really just want to repeat this. If you have flaky tests, if you have flaky infrastructure, they are the devil. You need to root these things out, right? And if you can't fix a flaky test quickly, disable it, put an item in the backlog to address it later on. But do not let flaky tests be kind of the Russian roulette of pipeline success, because that will end in tragedy, right? Same with flaky infrastructure. If you can't fix your flaky infrastructure, you might have to commit resources or people to it. You may have to do some re-architecture or something like that. And then when it comes to things like bad commits, bad merges, deployment failures, and so on, you address those on a case-by-case basis. If you're tracking a lot of failures coming to an individual or a team, maybe that individual needs some coaching. Maybe that team is working in a tricky or legacy part of the code that isn't well tested. Maybe we need more testing, more unit testing, those sorts of things. Moving on to our service level agreements or actions for the fast feedback, fast failure objectives. Mean elapsed time. This is the frog in the frying pan. Keep a close eye on that, right? Because what takes 5 minutes today takes 6 minutes next week, 7 minutes the week after that, and then before you know it, you got an hour-long build, and you don't want that, right? You don't want that. There's lots of tooling available out there to compile and test in parallel. Maven, Gradle, Make, lots of products out there, including ones from CloudBees, of course, that will allow you to run your pipelines in parallel, run your testing in parallel, run pipelines in parallel, even use elastic infrastructure so that you can do this, all of those kinds of things. Look for the longest serial chain in your pipeline. That's going to be the thing that sort of limits how fast your pipeline can run. Go chop that up into smaller segments if you can. And if you're able to, throw hardware at the problem, right? If you're lucky, you're able to break this into multiple segments and you can run these things in parallel. And that's in particular the case with, say, system tests, right? Oftentimes we end up running system tests serially because if we run two system tests, against the same instance of a system, they might interfere with each other. One might be doing something that we're measuring or trying to test with the other. And so we tend to very often run system tests in parallel. Well, if you could throw hardware at the problem and fire up and install or deploy multiple containers with your system in it, with your application or your service in it, and then run all of those tests or test suites in parallel, then you can dramatically collapse your time. We just did this exercise in one of our product teams there at CloudBees, and we were able to, by a factor of between 4 to 8x improvement in our system testing time just by using that approach of deploying the application to multiple instances of environments in parallel and then running those tests in parallel. We were able to dramatically collapse the length of our system test pipelines. Mean time to failure. If failures are happening later in the pipeline, then I sort of talked about this a little bit earlier, but look at whether these are system test and integration test failures, and really what you ought to be doing is maybe writing better and more unit tests. Unit tests tend to run earlier in pipelines. They tend to run more quickly. You can write more of them. And really, again, what I encourage our teams to do is, look, if you end up with a system test failure, or even an integration test failure, always ask yourself the question, could I have caught this earlier, right? Generally speaking, too, later state failures are going to be more tricky to address. You might need access to the environment to debug or diagnose the failure, right? Again, if integration tests or system tests are taking too long to run, consider breaking them up into smaller batches and run them in parallel. And take advantage of elastic infrastructure to do that. Take advantage of being able to deploy your applications as containers, if you can do that, in order to be able to parallelize and collapse the cycle times here and find the problems faster. Again, it's not just about how long is your cycle time, but really how quickly can we find the failures, and because that impacts how quickly we can address the failure and how quickly we can kick off another pipeline that will address the problem, or restart an existing pipeline at the failure point. So thank you very much. Kind of in summary here, decide on your desired outcomes, select the indicators that are relevant or metrics that are relevant to those outcomes, measure against those objectives, and then have agreements or actions in place for when you miss those objectives. It's really, that sounds very simple. I know it's a much more complex thing to accomplish than that, but really, if you go after it that way, think small, think incremental improvements, but be ambitious. Be ambitious at the same time. You will be able to control and drive improvements in the outcomes in your pipelines. And I'll leave you here with a screen just of a few resources here that were useful to me and that I drew from in putting together this presentation. thank you very much for listening and watching. I wish we were doing this in person so we could interact a little bit and have Q&A and those sorts of things in person, maybe next year. Thank you very much for listening today.